The transition to a machine-driven economy is already happening. AI agents are rapidly moving out of research labs and interacting directly with active financial networks. But right now, we face a physical bottleneck. Most artificial intelligence is trapped behind a screen. It can analyze massive datasets and write complex code, but it cannot execute physical tasks or directly manage capital without a human stepping in to approve the final action. This diagram breaks down the core limitation. On the left, the Web 2 setup. AI operates as a smart autocomplete, requiring constant human supervision. On the right, the Web 3 solution, an autonomous collaborator designed to orchestrate complex smart contracts and execute strategies entirely on its own. Giving AI direct control over physical robots and financial wallets unlocks autonomous commerce, but granting agency to a system prone to hallucinations introduces severe financial and operational risks. We call this the Oracle Problem 2.0, as outlined in this vulnerability schematic. If an autonomous agent relies on unverified off-chain data, like a centralized API, and that data is compromised, the AI will confidently execute a flawed transaction, resulting in permanent financial loss. Because blockchain transactions cannot be reversed, an AI system cannot operate on assumptions or trust. It requires a rigid environment where every single input is mathematically verified before any code is ever executed. That environment now exists. The Denarii Research and Testing Laboratory is an integrated testbed designed to merge decentralized finance, artificial intelligence, and physical robotics safely. Inside this facility, engineers are building the central nervous system for a fully automated economy. We start in the AI compute facility. This is where high-level economic intents are formulated. The scale of intelligence here is massive. The Denarii agency operates 232 specialized AI models, each trained to handle highly specific domain tasks, like supply chain procurement or market analysis. This diagram illustrates how hundreds of models are managed. At the center, an executive orchestrator coordinates 12 specialized executive nodes. Looking at the sidebar, these 12 modules operate inside hardware-isolated, trusted execution environments, ensuring reasoning processes remain private and immune to tampering. By replacing human corporate management with a cryptographically verified intent engine, the system guarantees that every strategic decision is logged, auditable, and mathematically secure. Once a decision is made, it moves to the robotics laboratory. This is where digital intent translates into physical force. Platforms like the Unitree G1 and the Figure 02 make up the primary humanoid workforce. They are equipped with highly dexterous hands and advanced vision-language action models, allowing them to navigate human-designed spaces and handle complex assembly tasks. For logistics requiring heavy lifting and continuous, zero-intervention operation, the lab deploys industrial-grade machines like the electric Boston Dynamics Atlas, capable of managing 50-kilogram payloads and swapping its own batteries. Populating this physical testing ground requires investment, detailed in this matrix. It covers robotic arms, 3D printing arrays, and servers. Zooming in, we see autonomous mobile robots and IoT hubs acting as the digital eyes of the facility, feeding real-time data back to the AI. These platforms act as direct physical extensions of the AI executives, executing the complex intents formulated in the cognitive layer through real-world actuators. Moving physical goods has no economic value unless the machines can pay each other. For that, we enter the blockchain infrastructure data center. The entire facility anchors its financial operations to the Flare network, a decentralized ledger optimized specifically for verifiable computation. This blueprint maps the Flare stack. The critical piece is the Flare data connector in the middle layer, acting as a cryptographic gate. It mathematically proves external events happened before execution. Once verified, it triggers smart accounts to automatically execute transactions without human sign-off. This settlement layer provides absolute financial sovereignty. Machines can now hold their own funds, negotiate prices, and procure their own resources. When you link these three systems, you get a seamless, real-time loop. A delivery drone visually confirms a package drop-off. An AI executive evaluates that sensor data, and a smart account instantly settles the payment to the drone's wallet across the network. Every action inside the Denarii lab is governed by a strict philosophy outlined in this graphic, the way of the verifiable executive. The first two principles dictate that an agent must gather federated evidence to observe reality and rely exclusively on cryptographic proofs to verify it. Opinions and assumptions are entirely removed. The final rule demands that the AI's fluid, adaptive intelligence remains strictly bounded by deterministic smart accounts. It thinks freely, but acts only within pre-approved parameters. The result is a system of immense precision, a physical entity capable of adapting to its environment, innovating solutions, and executing with flawless accuracy. The Denarii laboratory demonstrates that when continuous AI reasoning, robotic embodiment, and verifiable blockchain settlement converge, the machine economy moves beyond the digital screen and into the physical world.